Now, check my numbers, but everybody seems to agree. These are the densities I get at the corners, and those are obvious. You just plug the coordinates of the corners into this function, right? And then at the center, which is I think 4.50, we get a density of 4.5. Average density at the corners, 5.06. These differ. Due to the nonlinearity of y over x, right? But it means that if we average the corners, we're not too far off. Now maybe we do a weighted average. Maybe we weight the average of the corners with the average at the center. Or a weighted average where we do 2 times this plus 7.3 times this. Okay? Well, there are various approximation techniques that you get in kind of a little bit of numerical analysis, but we're not going to worry about that right now. We're just trying to get the concept of how these densities somehow give us an average density, which we then multiply by the volume, right? So if we estimate an average density of 5, which is not an unreasonable estimate, we get a total mass of 150 because the volume is 30, I think. Do we agree that the volume is 30?
Yeah.
Yeah. So, okay, using density estimate, and I'm going to use both estimates. And I'm just going to use 5 and 4.5. That 0.6 doesn't really mean much because we know, because these don't agree, and because of the nonlinearity of this thing, that, you know, just rounding off to the nearest tenth or even nearest half is probably going to give us a pretty good idea of what the possible range is, okay? That's 135, right? Yeah. Okay? And I'll say the actual mass is likely in or close to this range. And I'll also just note that the volume's 30, and that should be completely obvious. You got a 2 by 3 rectangle, 5 units high. Area of the base is 6, area of the base times the altitude's 30. Okay? So, how can we refine this? Think about it a little bit.